This is video number 3. We're going to be talking today about grams to mole conversions and how to convert from grams to moles of a molecule and back again. But before we do, I want you to look at page 147 and make sure that you've already done your Cornell revisions, questions, and summaries for that day. All right, the other things you're going to need for today's video are your periodic table, your flip-up periodic table from the back of your notebook, a calculator, and of course something to write with. So on page 149, write down today's essential question. How do you convert grams of an element to moles of an element? And how do you convert grams of a molecule to moles of a molecule? So remember that in order to do any converting from grams to moles of a substance, you need to use the molar mass. Molar mass is expressed in some number of grams per 1 mole of that substance. A common problem that chemists have is they often flip-flop the moles and the grams. So look on the periodic table, look at the number below the chemical symbol. That is the amount of grams for 1 mole of that substance. So often students will flip-flop this. They'll write 12.01 moles of carbon, for example, for 1 gram of carbon, and that's incorrect. So I want you to think of this analogy. Think of a giant whack-a-mole game. And the periodic table is like one big, giant whack-a-mole game. So in every whack-a-mole game hole, only 1 mole will pop out. So here's a picture. You see only 1 mole pops out of every little hole. And the periodic table is just like that as well. Every symbol on the periodic table represents 1 mole of that substance. So write this part down. Only 1 mole pops out of each box. That means only 1 mole of that substance is equal to that element's molar mass in grams. Every little mole on the periodic table has a different mass. All right, so in the interest of good practice, here is the photo credit for our molar mass game. All right, so our next topic is being able to convert from grams to moles of an element. So here's an example. How many moles of magnesium correspond to 12.15 grams of magnesium? Write the question down and take a moment to set up what you're given and what you need to find in this problem. All right, you're given, the first thing that you're given, this 12.15, comes directly out of the word problem itself. 12.15 grams of magnesium. It's not enough to say 12.15. It's not enough to say 12.15 grams. You have to say what it is you're measuring. So 12.15 grams of magnesium. We also know from the periodic table that in 1 mole of magnesium, the mass will be 24.31 grams. I just got that number right off the periodic table. And remember, we're only going to round to about 2 decimal places in this class. What is it we're trying to find? Blank number of moles of, specifically, magnesium. So given the fact that I have a initial quantity and a ratio, I see that I need 2 pickets in my picket fence. So set up a picket fence with 2 pickets. Here's mine. The first quantity that you're given from the problem is what goes in the very first picket, 12.15 grams of magnesium. Now we know that we need to get rid of grams of magnesium to get all the way to moles of magnesium. So I'm going to choose to put grams of magnesium on the bottom for the ratio portion of the picket fence. So 24.31 grams of magnesium for every 1 mole of magnesium. That goes on the top. Punch that into your calculator. The solution is, I got 0.499999, but rounding to 2 places, I get something like 0.5 moles of magnesium. Now remember, a complete answer can't just be this number. It can't just be this number. It has to be the unit and the substance that we're measuring. So let's try another example. We're going to now go the other way. We're going to convert from moles to grams of an element, an individual element. So we'll write down this example. What is the mass in grams of a sample that contains 1.38 moles of nitrogen? See if you can set up what it is that you're given and what it is you're trying to find. All right, in this problem I'm given 1.38 moles of nitrogen. I look to the periodic table to find this number. The a mole of nitrogen has a molar mass of 14.01 grams. So I write that down as the ratio that I care about. Now, this is a two-step process. I'm going to need 2 pickets in my fence. So go ahead and draw your picket fence. As always, the word problem starting point is what goes in your very first picket, moles of nitrogen. Because we want that unit to cancel, of course, we have to put moles of nitrogen on the bottom and fill in the remainder of that molar mass ratio on the top, 14.01 grams of nitrogen. That corresponds to this ratio here, the one that I pulled right off the periodic table. All right, so I multiply through. Let me get rid of that. And I hope that you get 19.33 grams of nitrogen, just like I did. All right, so now we are going to take a look at how we do these conversions when you have a bigger molecule. So remember, we practiced a little bit today finding the molar mass of a molecule by adding the molar masses of the elements present in that type of molecule. So, for example, what is the molar mass of water? Let's try this one. Now, what do we know? We know that in a mole of water, there is a mole of oxygen and 2 moles of hydrogen. So there's an implied coefficient of 1 here with the oxygen, and of course this this subscript of 2 for the hydrogen. So I just add up the molar masses of 2 hydrogens and 1 oxygen. You could do it like this, where you add each thing individually one at a time, or if you'd like, you can punch it into your calculator, multiplying using a multiplier for the things that you have multiples of. In this case, I've got 16.00 grams per mole of oxygen and 2 atoms of hydrogen, so I'll multiply 2 times the 1.01 grams. That's the molar mass that I got right off the periodic table. So when I'm doing these conversions between grams and moles of a molecule, the first step is to add up the molar mass of each participating substance. So let's try an example. The substance we're going to be looking at is salt, NaCl, sodium chloride. So given the fact that I have 3.5 moles of sodium chloride, how many grams do I have? You'll first need to find the molar mass of sodium chloride by adding up the molar mass of sodium and the molar mass of chlorine. And then we'll need to set up a picket fence to do this. So see if you can write your given and find. All right, the problem tells me I have 3.5 moles of NaCl. The molar mass of NaCl is the 22.99 grams per mole from sodium. I add that to 35.45 grams per mole of chlorine. And what I got is 58.44 grams of NaCl for every 1 mole of NaCl. So I'm going to need 2 pickets in my fence yet again. In the first bracket, I want to put my starting quantity from the word problem, the 3.5 moles of NaCl. I need moles of NaCl to cancel, so I'm going to use the ratio that contains moles of NaCl, and that's this ratio right here, this one that we came up with. So I'm going to plug in the 1 mole of NaCl on the bottom, that'll make these two cancel. I'm going to put the 58.44 grams of NaCl on the top. When I cancel out these units, as you can see, moles of NaCl cancel, moles of NaCl cancel. I'm left in units of grams of NaCl, which is exactly what I wanted. So punch that into your calculator and tell me what you come up with. I got 204.54 grams of NaCl. In other words, in this 3.5 moles that I started with, it will have a mass of 204.54 grams. So let's try one more example, and in this case we're going to convert from grams to moles. So here's our example. How many moles of C2H2 in 100 grams of that same substance? So set up your given and find. you'll need to add up the molar mass of this whole C2H2 compound. All right, given that you're starting with 100 grams of C2H2 and you're trying to find some number of moles of C2H2, I need to take 2 carbons, 2 times the molar mass of carbon, which is 12.01, and add that to 2 times the molar mass of hydrogen, which is 1.01. When I do that, I come up with this molar mass ratio. This is the ratio I'm going to use in my picket fence. For every mole of C2H2, I've got 26.04 grams. All right, so we'll need 2 pickets in our fence yet again. This is a 2-step process. Here we go. The quantity that is in the word problem is where I start. Because I need grams of C2H2 to cancel, I'm going to use grams of C2H2 on the bottom. I'm pulling this number directly from this molar mass ratio we just came up with. So what is attached to this is the 1 mole of C2H2. That'll be the one that I put on top, just like that. So before I calculate through, I want to make sure that my units cancel. Grams of C2H2 cancels with grams of C2H2. I'm left in moles of C2H2, which is what I want. That's what I was trying to find. Punch that into your calculator. Make sure that you're getting the same thing I am. All right, 3.84 moles of C2H2 is our final solution. So in this video, we've shown how to convert between moles and grams of an element on its own and of a compound. So this is a skill we're going to continue to practice tomorrow, Friday. So finish up your Cornell notes on this page. You don't have to do revisions, questions, and summaries today. You'll do that tomorrow. And I look forward to seeing you. Have a good one.